Hi students, welcome to section 7.2 where we are going to look at inverses of relations in functions. So what an inverse is when you have an expression written, it is a function that undoes another function. It totally does the opposite. It inverses your original expression. And while I'm talking, notice you can already get written down our lesson objectives and the vocabulary, inverse relation and inverse function. So, what a relation is simply when one piece of data is related to another. And we usually show that as an XY point. When you have a certain X, you have a Y with it. And they are related to each other. Now, what a function is it is a relation, but it has a little bit more to it. For each input, for each X, there is one and only one output. And that is not true with a relation. With a relation, any two pieces of data can be related. So, our lesson objectives are we want to graph and recognize inverse relations and functions, and we are going to find our own inverse functions. An inverse relation is switching the x and the y values of an xy point. So that sounds pretty easy, and you'll see later that it is. An inverse function, as I said, is a function that undoes another function. Okay, so what we're going to do is you see this chart here, but this chart we are going to come back to. We're actually going to do that last. And there's good reason for that, and I'll show you why after we move on. So let's look at our next notes. Our next notes on 7.2 is they give us a lot of information here. Oh, sorry about that. That's the second page. Sorry. Here's your second page. There you go. Didn't mean to confuse you. Here you go. So, inverses of relations in functions. So what they show you here is they have a chart that has a set of XY points, 0, 3, 1, 6, 4, 9, and on, and you can see. And that is called a relation, which is just a set of ordered pairs or points. Okay? If you remember, domain are the x's. And when you look at the x's, you can see they go from a low of 0 to a high of 10. And that's why you can see here that they listed the x's between 0 and 10. If you remember that range is the y values, that's kind of easy to remember because x and y are in alphabetical order, and so is domain and range. So range is the y values. Notice our y values go from a low of 3 to a high of 11. And so this is how they list the range, that y is in between 3 and 11. And what they did is they simply plotted the points that are shown in the chart above and then put a smooth curve through it. Now let's look to the right here. To write the inverse of a relation, you simply switch the x and the y. So isn't that super easy and nice? We had the point on the left, 0, 3, and now we have the point 3, 0. We had the point 1, 6, and now we have the point 6, 1. Again, we had 4, 9, and now 9, 4. So isn't that kind of nice and easy, which is great. Now, let's take a look here at what is the graph doing here. They have included this line right here is the y equals x line. Now, that isn't part of the first chart or the second chart. There is a good reason why they put the y equals x line here. Okay, so let's take a look. What they've done is here in red is the original relation that they graphed. You can see it here in here. What you see below is this is the inverse that they graphed, right? Here's the 0.30 right here, 6,194. You can see where they graphed these points in blue. So we'll put blue here. There we go. When you draw the y equals x line, which is that diagonal which goes straight across the chart, you can see that the relation and the inverse of the relation are symmetric to each other. If you folded on this y equals x line, the red curve and the blue curve would match up. I think that's really cool, because why does that happen? Well, the y equals x line, that's exactly what you did. You made the y equals x and the x equal y. You flipped those values, and so the pictures also flip over that line. So let's look below. Complete the table to find the ordered pairs of the inverse, graph the relation and its inverse, and identify the domain and range of each relation. So great, in blue they give us the relation, and here's my x's, here's my y's. All I'm going to do for the inverse is inverse those points. So we had 0, 6, I have 6, 0. So all I'm doing is flipping the xy points that I see above. Awesome. Okay, now let's go below. Here's our original relation with the blue star, and let's write the domain of this relation. So we're looking at the x's. Notice the x goes from a low of 0 to a high of 10. So I'm going to say that the x is in between, it's greater than or equal to 0, and it's less than or equal to 10. Let's look at the range of the relation right here. Notice that the lowest y value is a 6, the highest is 13. So my y's are in between, or they are greater than or equal to 6, or less than or equal to 13. Now, let's go on over to the inverse domain and range. And again, we're looking at the second chart, and we're looking where the red stars are. So let's take a look at the domain. The domain now goes from 6 to 13, right? So those x's are in between 6 and 13. And my y's, or the range, is now in between 0 and 10. So my y's are in between greater than or equal to 0, less than or equal to 10. If you notice, this perfectly makes sense. When you switch the x and the y's in the chart, because domain and range are x's and y's, of course the domains and ranges switched also. Now let's go ahead in blue. Here's the y equals x line, and let's graph the points in the relation. So we have 0, 6, 2, 10, 5, 12. Here we go, 8, 13. And we have 10, 13. Here we go. Makes a nice curve. Let's go ahead and graph the points in the inverse. We have 6, 0, 10, 2, 12, 5, 13, 8, and 13, 10. Here we go. And when we connect the red points in a curve, you can see once again that the relation and its inverse are reflected over the y equals x line. Let's move on to writing our own inverses. So here is our last page. We are going to go back to the first page when we're done here, but let's go back. So when you take a look here, there's a lot of information. I don't go over all of it just because it would take a long time, and it's there for you to read anyway. So if you have a function f of x, I have circled in green, If you write the inverse function, you would write it as f with an exponent of a -1 x. So here is a function and here is its inverse. How are these two related to each other? If you have a function where you input an x and you get a y out, when you write the inverse function, when you input that y, you'll get the x value out. They undo each other. So what we're going to do is inverse operations to write our inverse function. So when you have the function f of x equals x plus 8, the inverse of plus 8 is minus 8. So to write the inverse, I will have the x with the inverse operation minus 8. Okay. What about if you have the function f of x equals 5x? This function means when I put in a value for x, I multiply by 5 and get my y out. To write the inverse, this must mean that I would have to divide x by 5, the inverse operation, and that would be the inverse function. And when you try points, you will see that they are inversed also. And I'll show you what I mean. Let's go to the function on the left, x plus 8. Notice when you put a 1 into this function and do the math, 1 plus 8 is 9. Your output is a 9. Notice then that the point, if this really is the inverse function we wrote, it should switch the x and y point. That when I put a 9 into this inverse function, 9 minus 8 is 1. I really do get the inverse points from the inverse function. So let's go below and let's write some of our own. Let's take a look here. I talk my way through it. My function is x minus 4. The inverse of minus 4 is plus 4. So my inverse function must be x plus 4. And now it says use x equals 5 to check. Okay. When we put x equals 5 into the original function and do the math, when we put a 5 in, 5 minus 4 is 1. Let's go to our inverse function and see if the inverse point works. When I put a 1 into my inverse function, 1 plus 4 is 5. It does work. Let's take a look at number 3. On number 3, x is being divided by 6. Again, we are being asked to write the inverse function. So, the inverse function would be the inverse of dividing by 6 is multiplying by 6. And it says use x equals 12 to check. So let's take our original function, x divided by 6. And when you put a 12 in, 12 divided by 6 is 2. Okay, let's check and see if we really wrote the inverse function in blue. If we did, when we put in a 2, we should get a 12 out. Let's take a look. When we put in a 2, 6 times 2 is 12. We did write the inverse function. Now, I believe if I'm right, on number 4, I think we've kind of done enough here, and I don't believe that we need to do the same process for x plus 3 and for 14x. What we need to do is go back to the front page and do a relation, a function, and write its inverse function that has more than one step, because that's what your book does. Okay, so we're going to fill this chart in a second. Well, we'll start right here. Let's start with a function. Let's try, let me check what we did before. Great. Just wanted to check if 2x plus 3 as a function would give you something different to do. Okay, now let's go below here. When we wrote our inverse functions on the last page, there was only one inverse operation to do. Here we have two of them. So I'm going to write out what's happening in this function. First of all, when you take your x, it's first being multiplied by 2, then you are adding 3 to get your y value. So you're first multiplying by the x by 2 and then adding 3. So to write the inverse function, you have to be a little careful here. You probably already know that the inverse of plus 3 is minus 3, and you know that the inverse of multiplying by 2 is dividing by 2. What I need you to know is that when they wrote the function, we went to the right. You first multiplied by 2, and then you added 3. So when you write the inverse function, you not only have to do the inverse operations, but you have to do them in the inverse order. So we have to first subtract a 3, then divide by 2. So to write the inverse, we have to take our x and first subtract the 3 and divide by 2. Okay, now let's check and see if our function and our inverse function actually undo each other and make an inverse point. So let's take a look here. Let's say that we decide to put a 1 in for x. So we're going to put in a 1 for x, and we're going to do the math. 1 times 2 is 2, plus 3 is 5. So when we put in a 1 into our original function, we get a 5 out. That would mean that our inverse function, when we input a 5, we should get a 1 out. So let's see if that is true. When we put a 5, 5 minus 3 is 2, divided by 2 is 1. And in fact did work. So let's do the whole trail here. When we input a 1 into our function, we get a 5 out. When we input the 5 into the inverse function, it outputs a 1. And there we really did write the inverse. So thanks for doing 7-2 notes with me, and have a wonderful day.